Lesson 26, Science 8, and today you're going to be introduced to a new phenomenon. So grab your pencil, your journal slip, and your science journal. The video you're about to watch is going to showcase an emergency situation that requires rescue workers to respond to the scene. As you watch, be on the lookout for a problem that arises. Your goal is to identify this problem so that we can figure out a solution. Ready? Here we go.
Come on, let's check the next floor.
Abby, how stable is this building?
After the earthquake, not sure, but we don't have much time to evacuate any survivors.
Abby, I think I see someone. Are you okay? Can you hear me?
She's breathing and she has a steady pulse, but she needs to get to the hospital. Clone our position.
My battery's dead.
Wonderful. Use mine.
Your battery's drained too.
You can get up now, Anna.
Good thing it's just a test drill, right?
Well, it could be worse. Guess we still have working flashlights.
Guys, we have to find a way to keep these batteries charged.
Hey, you must be the rescue workers. Welcome to the Energy Research Lab.
Thanks.
So, I hear your batteries died during a drill.
Yeah,
If it would have been a real emergency, we would have been in trouble.
serious trouble. We rely on the radios to communicate with emergency workers like police, fire departments, hospitals.
And we don't know how long we're going to be in an emergency situation. We could be out there for a while.
It's not feasible to plug your devices in to charge while you're on that rescue mission.
We can't count on it. We could be out in the wilderness or the power grid may not be working. Even if it is on, we may not be in one place long enough to charge it.
Okay. So, what you really need is a portable energy source that can power a small device.
But not just radios. We have GPS and flashlights.
Got it. We'll put the team to work and be in touch when we have a few designs.
Sounds good.
Thanks.
Okay, so although the characters in the video and the Energy Research Lab are fictional, this context can certainly happen in real life. In the video, we saw that the small devices the rescue workers were using, their flashlights and radios, ran out of charge. Make sure to mark this problem on your journal slip. So, we need to figure out a way to provide energy for those small devices in the event that they can't be plugged in and charged. This is especially important in missions that happen during storms that cause the power to go out, or in missions that occur in the wilderness, or in missions that take rescue workers into dark tunnels. So here's our driving question. How is it possible to charge electrical devices when the power is out? You can also mark this down on your journal slip. To figure out a solution for the rescue team, we first have to ask ourselves, what is energy? And does it even matter to the rescue team? Knowing this can help us begin to understand how we can offer a solution to the rescue team. Today, we'll focus on the first part of the question and decide just what we mean by the term energy. So how would you define energy? Take a moment to think of a definition and say it out loud. Yep, say it out loud, right to the screen. So maybe you were thinking energy has something to do with movement. Well, according to the Energy Research Lab, energy is the ability to make things move or change. I want you to keep this scientific definition of energy in mind as we think about objects that might possess or contain energy. Another way to say this is that whenever something moves or changes, it's because of energy. Let's keep this key concept in mind as we think about different objects and whether or not they have energy. I have a set of 16 object cards here on the screen. These 16 cards are also attached to your journal slip. I want you to cut out all 16 objects and sort them based on whether you can see evidence of energy or you can't see evidence of energy. Take a moment to pause this screencast and think about where each object belongs. Think about the definition of energy as you look at each object. Do you see evidence of energy? If you can't see evidence of energy, drag it to the object bin right on the left. If you can see evidence of energy, drag or put the object to the bin on the right. Leave the objects that you're unsure of outside any bin or outside any place in the chart. Go ahead, do this now. All right, let's start with the card of the fan spinning. Where did you put this? Well, I can tell from this image that the fan is moving. Remember, energy is the ability to make things move or change, so the fan must have energy. The same is true for the soccer ball moving, the water falling, a skateboard moving, and a person turning a hand crank generator. All these objects are moving. When an object is moving, it has a certain type of energy. We call this kinetic energy. Some objects, though, have stored energy. Even though they aren't currently moving or changing, they have the ability to make things move or change in the future. We call this potential energy. Food, charged battery, a stretched bow and arrow, a skateboard at the top of the ramp, and even gasoline. Each of these objects has the ability to make something move or change. Food is going to make a person's body move. A charged battery will make a toy robot move. The stretched bow and arrow will make the arrow move when it's released. And the skateboard at the top of the ramp will move down the ramp. And the gasoline is going to make a car move. Now, some objects like light don't belong in either bin. We're going to leave these objects related to light energy outside the bin. These things do have energy, but they don't quite fit into our two bins. We'll just leave them outside the bin and term them light energy. Also, the fan not spinning and the soccer ball not moving don't have kinetic energy because they aren't moving. And it doesn't appear that they have the ability to make anything move or change in the future, so we can't put them under potential energy either. We can leave these objects outside the bins as well. So we figured out that when something is moving, it has kinetic energy. But when something has the ability to make things move or potentially change in the future, that something has potential energy. Write these terms and their meanings on your journal slip. So now that you've learned about two different categories of energy, let's think about how these two forms of energy might be involved in the rescue team's missions. I want us to connect what we're learning in this lesson to the phenomenon. So think, what's one way that kinetic energy might be involved in rescue team missions? And what's one way that potential energy might be involved in rescue team missions? Take a moment to answer these things on your journal slip. Okay, what did you come up with? Well, when the rescue workers are moving and running from place to place, they're definitely exhibiting kinetic energy. Or maybe they're moving around in their rescue vehicles. Those vehicles possess kinetic energy as well. Now remember that potential energy is stored energy. The batteries that they're using to operate their radios and flashlights have stored potential energy. And the food that the rescue workers might be eating also has stored potential energy in the chemical bonds. Put this down on your journal slip. If you had some other ideas, that's fine too, but you should make these additions. For today, submit your journal slip. And until tomorrow, I want you to keep thinking, keep learning, and get ready because we're going to think about how energy changes form.